Okay, so we're ready to sketch a rational function. And we mean we're going to graph it. We're just going to do our best. Okay, so we're going to follow the steps. First, we're going to find the y-intercept. To do that, we find f of 0, and that's going to look like 2 times negative 3. Remember, I'm putting in 0 for x. 1 squared times negative 2. So that's going to be what? Negative 6 over negative 2, which is going to be 3. Okay, that gives us a point then that we know right there, 0, 3, the y-intercept. Okay? Now, the numerator and denominator are already factored. So step 2, we don't have to do that because it's already done. Already done. Done. Okay, so that was step 2. Step 3. X-intercepts. Now back on step 2, do you see any factors that are going to cancel? No. So this is not going to have a removable discontinuity. Okay. So now step 3, we were looking for the x-intercepts. And so we're going to take the numerator, x plus 2 times x minus 3, and set that to 0. And so we're going to get x-intercepts at negative 2 and 3. So we can graph those points. Negative 2 and 1, 2, 3. Okay, so we've got those points graphed. Now what do we want to find? Oh, the multiplicity. So the multiplicity at the x-intercepts is 1. So multiplicity is 1 here and 1 there. So they're both going to cross on the x-axis. Okay? All right. Now we're ready. That was step 4. Step 5. Now we're ready to find those vertical asymptotes. So you look at the denominator. So we're looking for vertical asymptotes. And we look at the denominator and say, when does that equal 0? So we're going to have a vertical asymptote at negative 1 and 1 at 2. So I'm going to put these in orange. So negative 1 and 2. Can't draw a dotted line today. Okay, and now step 6. By the way, step 4 was the multiplicities. Okay, step 6. What do we want to do there? Oh, there's no, it's done. There's no removable discontinuity. Okay, and then step 7, we have to do the horizontal asymptotes. Well, the degree of the numerator is going to be x squared, and the degree of the denominator is going to be x cubed. So that means we're going to have a horizontal asymptote at y equals 0. So we'll draw that in right there on the x-axis. Now, this is where I want to bring this up. You may be concerned that there are 2 x-intercepts and they're on that horizontal asymptote. That's okay. You're allowed to cross a horizontal asymptote. You're not allowed to cross a vertical asymptote. Okay? So I'll say that again. You can, it's okay to cross a horizontal asymptote, but you can't cross a vertical asymptote. Okay? So you see we already have 2 points graphed, and 2 of them, those intercepts, are right on the horizontal asymptote. Keeps changing color on me. Okay. Now what do we do? Well, I think step 8 is, sketch the graph, right? Sketch. Well, we know a little bit. We know that in this middle section, there's kind of like 6 sections, right? 3 above the x-axis and 3 below. Well, we know in that middle section, it can't go toward the x-axis because then there would be an x-intercept. So it's got to go up this way, and it's got to go up this way. Now, where that u is occurring, well, you could plug in the point 1. You could find f of 1, And I think I did that earlier, and I think it was 3 halves, if I remember right. Let me check real quick. 3 times -2 is -6. And then 4 times -1 is -4. Yeah, so 3 halves. So it's a point, like right, it should have come down to there. Okay, so I don't know if I can erase it without erasing the whole thing. See, oh, good. All right, so it should have come down a little bit further. But it's doing something like this. It can't cross the x-axis because then we would have had x-intercepts in there, and we don't. Now I know my curve is touching that vertical asymptote. It shouldn't be. I just didn't draw very well. Okay. Now what do? Well, we do have some multiplicity right here. So that's at the vertical asymptote -1, right there. And we know it's going to go up the same way. So we know that this part's going to go up this way. I meant to do that in the black pen. It's going to go up that way. Now what's it going to do on the rest of it? Well, it's going to come on through. We know it's crossing. And then it's going to level off. It's going to approach that x-axis. Now, what about the other asymptote? This one. We know it's got an odd multiplicity. And so they have to go in opposite directions. So it's got to go down this way. And then it's going to cross, but then it's going to level off. It's going to kind of start to approach. We don't know exactly how it's going to approach, but it's going to be approaching the x-axis. Okay? It could have a little bit of a hump in there and then level out. But that's just a basic look then of what the graph looks like. And that's all we're going for, is a basic look of what the graph looks like. So you see the steps that we did, those are important, and then you transfer those to the graph. One of the things that we notice in this particular example is what's happening at the asymptotes, okay? If it's got an even multiplicity, it's going to go in the same direction, and if it's odd, it's going to go in different directions. The other thing that really helped us out on this problem was the fact that there was no x-intercept in there, so we knew which way the graph was going to go, okay? So that's what we're doing, and we just have this one example in the book.